3.7 Modeling using variation preparation. All right, so we have different kinds of variation. The first one we're going to be dealing with is direct variation. Okay. 3.7 Modeling using variation preparation. All right. Let's do some examples. The first example is write a variation equation for each situation. Use k as the constant of variation. Now, when they say direct, we know that means multiplication. So when they say direct, we know that means multiplication. So we end up with y is equal to k multiplied by x, right? Now, in this case, they say A varies directly as B. They said directly, we know we're going to deal with multiplication. We're going to put A in the first place instead of the y. The k is the constant, so we're going to leave that in there. And then they have their b as b. So we have A is equal to kb. Next, we have M varies directly as D. Okay, because they have M there. Okay, well, first of all, it says directly, so we know it's multiplication just like the previous one, but we're going to put M first. M varies directly. And when they say directly, that means multiplication. So that directly tells me there's multiplication there. That directly tells me there's multiplication there. And then we put as D. Then we finally have proportional. Basically means the same thing. We have F is proportional to A. So we have F equals K times A. And that is multiplication because it's proportional or direct. Okay. Let's try another one. Suppose Y varies directly as x, okay? Y varies directly means multiplication, as x. Y equal kx. And they say y is equal to 20. Y is equal to 20. We substitute it in there. When x is equal to 4. When x is equal to 4. So that basically means 20 is equal to 4k. Okay, so we solve for k by dividing both sides by 4. What if you do to one side, you do to the other. And that gives me k is equal to 5. Okay, we're not done though. So now we plug it back in. We write that y is equal to, but instead of k, now that we know k is 5, I'm going to substitute in there. I'm rewriting the original equation, y is equal to kx, except now y is equal to 5x. And now I'm going to plug in the new information they gave me. So we already used y is equal to 20, x is equal to 4 to find k. And now we're going to say, find y when x is equal to 9. So we say y is equal to 5 times 9, which means y is equal to 45. And that's our final answer. The perimeter of a square varies directly as the length of a side. Okay, so the square, the perimeter. Okay, so we can put P, perimeter, is equal to, they said directly, which means we know it means multiplication, but we have K multiplies, and multiplies by what? Well, they said the side, so I'm going to use an S. Okay, now they say a square with a side length of 9, okay, has a perimeter of 36. So we know we have 36 is the P, the perimeter, K stays, and S is 9. So we divide both sides by 9 to solve for k. How do we undo the multiplication of k by 9? We divide by 9. And whatever we do to one side, we do to the other. Cancel, cancel. And we end up with 4 is equal to k, or k is equal to 4. Then we go back and we rewrite the original equation, except instead of writing a k there, we write a 4 there. And we have 4s. Okay, next they give us some more new information. They say, find the perimeter of a square with a side length of 19 inches. So I say p is equal to 4 times 19, where p is equal to 76, just like that.